Right, number 20, the following is the graph of f prime of x. Find the interval or intervals on which f of x is increasing and or decreasing. So the first thing that we would like to do, this is a picture of f prime. So if I want to find out where f is increasing or decreasing, we want an f prime chart. Okay, if I'm given a picture of f prime and I'm making an f prime chart, since it's the same level, we will be looking above and below the x-axis. So this picture is above the x-axis until I get to b. So my f prime will be positive, and then it drops below the x-axis between b and c, so my answer will be negative there. Okay, and then when it's asking for the intervals on which f of x is increasing, I know that that's where f prime is positive. So, and I notice my graph just goes from a to c, so from a till I get to b, that will be where f is increasing. And if they did ask me to justify, which they generally do, that would be because f prime is positive. And then from b to c, that would be where f is decreasing. And that would be because f prime is negative. Number 21, discuss the concavity of y equals x to the fourth minus 13/3 x cubed minus 8x squared. Okay, if we want to discuss concavity, we do need to get to the second derivative. And so we're going to take the first derivative. Y prime would equal 4x cubed minus, if I bump the 3 out front and reduce my power, I'll get 13x squared minus, bump my 2 out front and reduce the power, I'll get 16x. And then from here, we'll need the second derivative. So again, bump my 3 out front, I'll get 12x squared minus, bump the 2 out front, I'll get 26x minus this, it will just be 16. Okay, now from here we would like to set the second derivative equal to 0 so we can get our critical numbers. And before I try to factor that, I am going to, looks like 2 will go into everything, so I'm going to factor out a 2, so I'll get 6x squared minus 13x minus 8 equals 0. And then from here, I'm going to do the magic number trick. So I'll get 6x and 6x. I will need to divide by 6 eventually. And then from here, we'll take 6 times negative 8, which is negative 48. And then I'll be thinking what times what equals negative 48, but adds up to give me negative 13. And that would be negative 16 and positive 3. Okay, and then from here, we do need to divide the 6 back out. I notice I can't put 6 into either part, but I do notice that I can divide a 2 out of the first one and a 3 out of the second one, and 2 times 3 is 6, so it's going to all work out. So this one will reduce to 3x minus 8, and then this will reduce to 2x plus 1. And then we still set it equal to 0. So from here, the 2, I could really just divide 2 into both sides, so that's just gone. Now, if I set each of these parts equal to 0, I will get x equals 8/3 as a critical number, and I'll get x equals negative 1/2 as a critical number. Okay, we're still not ready to discuss the concavity because we do need to do a y doubled prime chart. Please notice that I'm calling this y double prime instead of f because there's no f in this problem. So I'll put negative 1/2 and 8/3 on my number line. And then if I test, I'm going to test negative 1 into my second derivative, I will get a positive answer. If I test 0 into the second derivative, I will get a negative answer. And if I test 5 into the second derivative, I will get a positive answer. So when it's said to discuss the concavity, I will say y is concave up on the intervals negative infinity to negative 1/2, and then 8/3 to infinity. And as I'm discussing, I will justify as well. And that would be because y double prime is positive. And again, it's not f double prime, it is y double prime. And then y is concave down on the interval from negative 1/2 to 8/3, and that will be because y double prime is negative. Okay, 22, find the absolute maximum of the function f of x equals x to the 4 over 4 minus 2x cubed plus 7 on negative 2, 4. Well, the first thing I need to know on an absolute maximum is to find a critical number, so I'm going to take the derivative. The derivative will be x to the third minus 6x squared. And then to get a critical number, I will take the derivative and I will set it equal to 0. I'm going to factor out an x squared, and when I do so, I'll get x squared times the quantity x minus 6 equals 0. So my two critical numbers would be 0 and 6. So this time, instead of doing an f prime chart, we actually need to test the function, the actual function at the endpoints and at the critical numbers. So we're going to have f of negative 2, f of 4, f of 0, and then I'm actually not even going to test f of 6 because 6 is not in the interval, so that will save us a little bit of work. Okay, so these are going back into the original function. Okay, so f of negative 2, if you plug negative 2 in there, you should get 27 as an answer. Plugging 4 in will give you negative 57, and plugging 0 in will give you 7. So when it says which one of those is the absolute maximum, a maximum is a y value. So the maximum y value this function reached on the interval would be the 27. So my absolute maximum would be 27 for that one. Number 23. The derivative of y equals cosecant to the 5th x is equal to what? All right, since I have it to the 5th power, I'm going to actually rewrite this, and I'm going to put it in parentheses. And then when I have parentheses, we generally are going to do a u substitution, so that's exactly what I'm going to do. I'm going to make this u to the 5th. So I'm letting my u equal the cosecant of x, which means my du, my derivative of the u, the derivative of cosecant, hopefully remember, is negative cosecant x cotangent x. All right, and then from there, so I have u to the 5th, so my derivative, the derivative of u to the 5th would be 5u to the 4th times the derivative of the u, and now I just need to plug in what I know. So y prime will equal 5. My derivative again is cosecant x to the 4th times my du would be negative cosecant x cotangent x, and then I'm actually getting to a one step farther. This negative is going to bump out in front, so it's going to be negative 5. And then if I have 4 cosecants here and another cosecant there, that would be cosecant x to the 5th. So we're going to have cosecant to the 5th x, and then I do have a cotangent x hanging out as well. Number 24, find y double prime if y equals sine of 8x. All right, so again, we're taking the second derivative. I do have some things in parentheses, so once again, this is a good candidate to do a u substitution, and I'm just going to write over here, my u is 8x, and the derivative of the 8x is 8. Okay, so finding the first derivative, my this is going to be the derivative of sine of u would be cosine u times the du. Well, my du is 8, so I'm just rewriting this. This will be 8 cosine u. I'm not going to plug my u back in yet because I know I have to take the derivative one more time. So my second derivative, the derivative of 8 cosine u would be negative 8 sine u, and then once again I have to multiply by the derivative, so I have to multiply by du, which is again 8, and so if I just simplify that, I'm going to get negative 64 sine. Now I'm going to put my u back in because I don't need to take the derivative anymore. So that would be my second derivative.